Every year, building collapses claim countless lives, whether caused by natural disasters, poor construction practices, lack of maintenance, or structures being pushed beyond their capacity. As urban areas continue to expand and population density increases, the risk and potential impact of such failures also grow. In the aftermath of a collapse, the difference between life and death often depends on how quickly aid can reach those who are trapped beneath the debris. However, rescue efforts are severely challenged when survivors are located in spaces that are inaccessible, unstable, or impossible to identify using traditional methods. To address this critical problem, we developed our version of the Mini Ant SAR, a miniature robot designed to assist in search and rescue operations during the most crucial moments following a structural collapse.
When looking at the capstone project provided, we discovered that our mini ant robot needed communication capabilities in order to aid in the success of search and rescue missions. More specifically, the senior mini ant robot design was full of sensors like cameras, thermal, microphone, and an antenna for communication with the user. To aid in the success of locating people for search and rescue missions, they made it clear that communication was one of the 4 main objectives. While initially we dabbled with this idea, but chose to focus more on the movement capabilities over the communication. After considering this new perspective, we determined that we needed to make our mini ant robot more user-friendly for the first responders trying to operate it. These communication capabilities could also double by helping to provide victims trapped in collapsed buildings with oral instructions on what to do next. Additionally, we also took inspiration from the senior's miniature ant robot's ability to jump and gain some vertical movement. In our miniature ant robot, we decided to add 4 spider legs to help the robot move vertically and over large rubble. We would like to credit the Nano Ninjas and their miniature ant robot for search and rescue missions featured in the Spring 2024 Capstone Design Expo for their inspiration.
So we noticed that in the experts design, they focused a lot on being able to communicate with the victims, and that there really isn't a point of sending in a rescue robot if you can't really do anything with it. So instead of engineering a robot to go inside and be able to come back out, we designed it to be as helpful and easy to work with as we could. We want to prioritize and empathize with the first responders as well as the victims and what the first responders want to get done while out in the field helping people rather than just simply trying to meet the basic criteria we were given. And so this is what allows us to push a project into something that was truly helpful and best for everybody and not just making some small throwaway device that can barely function and just isn't practical out in the field. And so we decided that in order to do that, we would implement arms for moving any rubble we could, because a lot of the time when trying to drive that car in there, it's never going to really be a straight path. And you always want to move something, especially in such an unpredictable environment. So anything that could make it easier, we implemented it. We also include speakers and microphone in our design so that we can communicate with the victims. The original expert design also had this, and it's for good reason. You have to be able to communicate with your victims, be able to give them everything they need to evacuate safely and keep themselves safe inside the collapsed building. And so we also implemented a push-push mechanism in our battery compartments, which protects the battery from dust and makes that robot last longer so it doesn't die out on you at the worst possible time. And when it does, you can very quickly switch out that battery. It's because every minute counts when you're trying to rescue people from a collapsed building. We implemented LED lights so that it could be seen easily by both the first responders and the victims, and to illuminate the surrounding area for victims to escape.
This project has given us valuable insight into solving real-world engineering challenges while balancing creativity with practical constraints. We're able to overcome difficult design decisions in order to streamline the development of our mini ant robot. SolidWorks provides us with experience in modeling precise components, understanding our design limitations, and visualizing the robot in its intended environment. Throughout the process, we learned the importance of clear communication, effective iteration, and thorough coordination. Through this work, we improved our skills in mechanical design, problem solving, teamwork, and CAD modeling. We also developed a stronger understanding of how each design decision impacts the success of a project, knowledge that will be applicable to our many other future engineering endeavors.